So a body of weight 500 newtons is lying on a rough plane inclined at an angle of 25 degrees with the horizontal. It is supported by an effort P parallel to the plane as shown in the figure below. So we have that force P acting parallel to the plane, and the plane is inclined at an angle of 25 degrees. Then we are required to determine the minimum and maximum values of P for which the equilibrium can exist if the angle of friction is 20 degrees. So what you can always do is to indicate the forces acting on the body. So after indicating those forces, one, we said we have our R, we have a frictional force. We have when frictional force is in that direction. We have also when the frictional force is in that direction. Then we have W. We have this angle which is the same as 25 degrees. Then we have W cos alpha. Then we also have W sin alpha. But we said for a minimum force P1 to keep the body in equilibrium. When it is at a point of just sliding downwards, force to keep the body in equilibrium when at the point of just sliding downwards. That expression is P2, which is equal to W sine into alpha minus phi divided by cos phi. We have already derived this expression and is up here. So you just substitute in the values given in that expression and you'll be good to go. Alpha is given according to this question. Alpha is 25, phi is 20, so alpha is 25, phi is 20 degrees. Weight is given also. Weight is 500 newtons. You just substitute in this expression and get your P2. So P2 will be 500 divided by cos of phi, which is 20 degrees, times sine of 25 minus 20. So this is 500 divided by cos of 20 times sine of 5 degrees. So using your calculator, you can get that answer. So 5 sine of 5, you divide it by cos 20. And P2 has been found. P2 has been found to be 46.37 Newton. So that is the minimum force required for equilibrium, okay, when the body is just about to slide downwards. So we have called it P2. So let P1 be the maximum force. Let it be the maximum force to keep the body in equilibrium when the body is just about to move upwards. So when it is just about to move upwards, we will use that expression. So P1 will be W times sine alpha plus phi divided by cos phi. So this is the same as 500 sine of 25 plus 20 divided by cos phi, which is cos 20. So that value will equal to 500 sine of 45 divided by cos 20. So sine 45 divided by cos 20 times 500. So the answer is 376.24 newtons. So the maximum force required is equal to P1 is equal to 376.24 newtons.